Hello, I have a question. How is ground source thermal conductivity at a site determined? I'm glad you asked that question. Maybe we should go through a discussion on thermal conductivity. Okay, that sounds interesting. With the 30% residential tax credit and the 10% commercial tax credit, it will drive many new installations to go with ground source heating and cooling. First to know is that the high solids grout can be measured for its thermal conductivity in the field. UBank has a device to directly measure the conductivity of grout that is built to ASTM standards and is easy to use. Secondly, UBank has a device that directly records the temperature responses during a test of an earth loop. Both devices also conduct the ASTM HDPE hydrostatic pressure tests. Okay, so this is not just N by golly. No, and before the work starts, let us review the design process. So this involves another trade on the construction site? Yes, drillers. And it can be messy. What is the design procedure for ground source? Well, it involves the facility, the local earth properties, and the ground heat exchanger. I know how to design the facility, but not about the other two. Okay, then let us talk about the facility first. The facility design is about the structure, location, orientation, occupancy, schedule, usage, and the systems including the indoor air quality. Facility designs gives the peak block loads. But we need to size the ground heat exchanger. And this requires the monthly heating and cooling loads, which is the usage. Usage is something new to the design process. Also we got the peak block loads, or the demand, from the facility design software. And we need additional software to size the ground heat exchanger. Carrier HAP and Train Trace has tutorials to get the usage and demand files from their software. Okay, what is next? Well, we need to determine the local earth properties. Okay, how do we do that? First, the thermal conductivity is the property of a material to conduct heat. This is the quantity of heat moved. Okay. Secondly, the thermal diffusivity is the thermal conductivity divided by the volumetric heat capacity. This is the rate that the quantity of heat moves. Okay, what was the third thing that is needed? It is the deep earth, the undisturbed or far field temperature. This is something new. An in-situ test can directly measure the thermal conductivity, the deep earth temperature, and the drilling log helps us to estimate the thermal diffusivity. Are there standards for this testing? Yes, UBank conducted the first in-situ test for our industry in 1994 and pioneered the methods. ASHRAE and IGSHPA then developed test standards. Has any continuing research been done? Yes, Dr. Rick Beer, Dr. Marvin Smith, along with UBank, did a sandbox test to valid methods and settled on the line source method. Where can I find information on UBank? At www.geotctest.com. Talk to Garen UBank.